And our ultra strength condition is offered in two different alloys, tungsten and 304V. First, we are going to talk about tungsten, and I will pass it over to Ross for that.
We're really excited to share the latest development in ultra strength tungsten, and we believe it could be a pretty good fit potentially for your applications. So overall, the motivation. So the motivation behind creating ultra strength materials, specifically tungsten and 304V, really comes down to the overall device downsizing. So as you design and build smaller devices, unfortunately, there's some mechanical performance loss just due to the sizes being used. So if we can provide a superior strength, this may help mitigate some of that loss that you see. Also, in surgical robotics, they can be very demanding on the cable systems, and primarily those cable systems are made of stainless steel or tungsten. So if we can enhance the resistance to deformation, it can significantly extend the cycle life of those cables and ultimately give better and more enhanced, reliable experiences for our patients. So let's share the diameter ranges we can produce with the ultra strength, and that will run at, say, 5/1000ths of an inch down to 5/10,000ths of an inch, where tensile strengths come to about 520 to 800 plus KSI. And it's good to note with those strengths, we're still able to maintain pretty good ductility at 2 to 4%. If you look at the right of your screen, the stress strain curve between 4A metals material and conventionally processed tungsten, you'll see a clear difference there. But not only that, it's good to note what's the area underneath those curves, which is the material's toughness. That is the ability of the material to absorb energy before failure. And if you can see and you can see the clear difference between the conventional and 4A metals high strength, which with 4A metals, it's about 3 times more energy absorption before failure than conventionally processed tungsten. As I noted, the 800 plus, this is where that plus comes in. We're able to almost hit 1,000,000 PSI at 12.7 micron in diameter. And still, again, maintaining excellent elongation. So this is basically the highest recorded strength that we could find for commercially pure tungsten. So potential applications, obviously, we just mentioned surgical robotics. If we can provide a harder material that correlates to better wear resistance, and it's less prone for plastic deformation. And downsizing cable configurations also could lead to better dexterity and device manipulation, catheter reinforcement. And then an area we are looking into is guide wires. So guide wire diameters. If you can provide an ultra strength, ultra stiff guide wire that could potentially aid in chronic total occlusions, where you could use that guide wire to pierce through an occlusion or occluded artery, could be very beneficial. So with that, I will hand it over to Garrett to talk about the 304V.
Thank you. Like Ross said, I'll talk a little bit about 304V ultra strength. The motivation for ultra strength 304V is generally the same as tungsten ultra strength. Again, we're looking to downsize some devices. An example is catheter reinforcement. If we can provide a stronger material, it may be the tipping point where you can make your catheter ID a little bit bigger so you can pull more through. But just overall strength in strands and braids as well could be a good benefit, and it also adds to the strength fatigue as well. To go into the stress strain curve for 304V ultra strength, The difference in strength isn't as drastic as the tungsten is. However, with typical high-10 material, which was our previous highest strength material in 304V, we see about a 30 to 50 KSI jump in tensile strength. So the sizes that this is available for is about a half a thou up to 6 thou inches. And we've been able to reach about 500 KSI while still maintaining pretty good ductility of 2%, which is very close to high-10 condition as well. Some of the potential applications would be catheter reinforcement. There could be some potential with springs with added stiffness, as well as guide wires, just the same as tungsten. The extra stiffness could be the thing that makes us able to go further into the body.